Welcome to lesson 10.2. Today we're going to be talking about how to find the area of trapezoids, rhombuses, and kites. First thing we're going to talk about is how to find the area of a trapezoid. That is covered by Theorem 10.4. To find the area of a trapezoid, we take half of the product of the height and the sum of the two bases. So if we have our trapezoid off to the right here, we've got our lower base down here, B2, our upper base, B1. We're going to add those two together and then multiply that by our vertical height. Again, the height needs to be perpendicular distance between the bases. And then once we take the product of the height and the sum of the bases, we're going to divide that by 2. So our first example here, we're asked to find the area of this trapezoid. We know our two bases. We've got a base here of 8, so we will say B1 is 8. And we've got our second base here is 14, so B2 is 14. Now the one thing we're not given is we are not given the height. So we actually need to find that, and how we're going to do that is we're going to use something we talked about in the last lesson. We're going to use that irregular figures part, and I'm going to change this trapezoid into a rectangle and a triangle. Now what that's going to do for me is I'm given this 45-degree angle right here. I drew a vertical line, so this is going to be 90. My third angle is going to be a 45-degree angle as well, and we've worked with 45, 45, 90 triangles. And I can find this length on the bottom. If this bottom whole thing is 14, this top is 8, that leaves 6 left for this triangle side. And since it's a 45, 45, 90, if this bottom length is 6, this length on the left is 6. So our height is actually going to be 6. So when we set up our area formula, we're going to take area is equal to 1/2 times my height times the sum of the two bases. Now the two bases added together, 8 plus 14, gives me 22. And if I take 1/2 times 6 times 22, I am going to get an area of 66 square millimeters. For the second example, again, I'm not given all of the information that I need. So again, I want B1, B2, and H. The only one that I am given is this top length here of 7. We'll call that B1. Now, very similarly to the first example, I can turn this into a rectangle and a triangle. Now, that does two things for me. First of all, this first part of the bottom length is 7. So that helps me find part of that length. And then the other thing is now I've got another triangle, but this time it's a 30, 60, 90 triangle. Now, if you remember from earlier, 30, 60, 90 triangles, they have the side lengths of x, 2x, and x square roots of 3. So the side we're given is 4, and that translates to 2x. So if I have 2x is equal to 4, I can find x by dividing both sides by 2, giving me x is 2. So I can take this 2 and plug it in for x in both sides and find my other two side lengths. So this bottom length is going to be a 2, and this length on the left is going to be 2 square roots of 3. So if I put that into my trapezoid here, I've got 2 on the bottom and 2 square roots of 3 on the left. So what that does for me is now I know the length of my B2. I've got a 7 on the left, and I've got 2 more. My B2 is going to be 9. And my height is now going to be 2 square roots of 3. So now when I go to write my area formula, 1/2 times my height, 2 square roots of 3, times the sum of the two bases, 7 plus 9. Now when I add the two bases together, I get 16. When I multiply these together, if I want to leave it as a radical, I can take 1/2 times 2 times 16, giving me 16, and then the square roots of 3 meters squared. If I want to round it to a decimal, I can say that that is about 27.7 square meters. So depending on how they want the answer given. It could be one of these two answers. The simplest radical form is the top, decimal form is the bottom. The next thing we're going to talk about is how to find the area of a rhombus or a kite, and that gets covered by Theorem 10.5. Now what we're going to do to find the area of either one of those, a rhombus or a kite, we are going to take half of the product of the length of both diagonals. So for each one of these, when we find our diagonal lengths, so for this rhombus, diagonal 2 is right here, diagonal 1 is right there. We're going to multiply those two together and then divide it by 2. Same thing with the kite. I've got my diagonal 2 length here, diagonal 1 there, multiply them together, and then divide it by 2. For our first example, we're finding the area of this kite here. We are given all of the parts to our diagonal. So if I want to find the whole diagonal, this one right here, I've got 3 on the top, 3 on the bottom, giving me a length of 6. For this other diagonal here, I've got a length of 5 and 3, giving me a length of 8. So my area will be 1/2 of the product of my two diagonals. So 1/2 times 6 times 8. If I multiply those together, I'm going to get 24 square centimeters. For my second example, I'm asked to find the area of the rhombus. Now here I'm only given 2 parts of each diagonal. I'm given this 25 here and this 22 down here. Now one thing we have to remember about a rhombus is it's a parallelogram, and in all parallelograms the diagonals bisect each other. So if this length is 25, so is this, making this whole length 50. And if this length is 22, so is this, making the whole length 44. So now I know my distances of my two diagonals. I can use my area formula of 1/2 times the product of my two diagonals. And when I multiply them together, I am going to get that it is 1100 square feet. Last thing we're going to talk about is just a little reminder from the last section. To find the area of a triangle, that's Theorem 10.3. We are going to take the area to be half of the product of the base and the corresponding height. Now again, base could be any of the 3 lengths. The height has to be a perpendicular distance from the base. And so once we've gotten those two identified, we take 1/2 times my base times my height.